Okay, welcome everybody. Today we'll talk about the numerical descriptive techniques. And we kind of hinted at this. We'll only have time today to talk about the central location measures and the variability measures. And you must have heard about some of these terms. So let's move on. Like the first measure, again, this is a very common measure. It's sometimes referred to as average, mean, or different things. So mean is a sum of all the observations over the number of observations. Okay. So let's say you have 5 observations of grades again for 5 students. 80, 85, 90, 95, and 100. 1, 2, 3, 4, 5. The mean can be computed as easily as the sum of these observations. So 80 plus 85 plus 90 plus 95 plus 100 over 5. So this will be, if I'm not wrong, it should be 90. Okay. So this is a very plain observation. Again, we'll use some other symbols. So we talked about population and sample. So if this thing is associated with the population, we'll call that mu. If it's associated with the sample, we call that x bar. Okay. So in the notation, if you want to write it in a fancy math manner, you can also write it like this. Again, this symbol, if you have not seen it, it's called the summation symbol. And this just says that I runs from 1 to n, and whenever you get a value of I, you sum that value. So if you want to go back to our example, let's call these grades. So let's call this x1, let's call this x2, x3, x4, and x5. Okay, let's go back and try to understand this notation. So, and again, the thing that's valid here is the sample mean, not the population mean, because this is a small sample of 5 students that we have taken. Okay, so if you want to calculate that, what the summation means is x bar is summation of I varies from 1 to, now the n is the number of observations. So n is number of observations. Here in our case we have only 5 observations in the sample, so n equals 5, and xi over n is again 5. Now summation means you take all those individual terms. So I, first value of I is 1, so x1. Second value of I is x2, 2, 3, 4, and we go up to 5, so plus x5. We sum all those values, and then this is what this is equivalent to, and then we divide by 5 to get our x bar. Okay, we can compute it the similar manner that we did here, and we can find out that value is 90. Okay, so that's arithmetic mean. Now the problem with arithmetic mean is it might be highly influenced or affected by extreme values. So one quick example to look at that is, let's say you have the salaries of 5 individuals. So again, 1, 2, 3, 4, 5. Let's say this is 20,000, 30,000, 40,000, and 10,000. Okay, let's say the 5th individual earned a whooping amount of $100,000. So now what happens to the mean of this data set? So the mean x bar is, the first is 20,000 plus 30,000 plus 40 plus 10 plus 100,000. Okay, over over 5 values. Now this thing is highly influenced by this 100,000. And what is this value? So 2 plus 3 is 5, 9, 10. So it's 110,000 over 5. And let me do the math for you. 110,000 over 5, it should be what? It should be a higher number. Okay, it should be a higher number. And let's make an example more interesting. If you say that 1,000, so it's like a million, then this number will be really high, and it will not be representative of either of these numbers. So this might be in a high range of $100,000. And are the people in my sample actually earning that kind of money? No. So mean is not a good representation when they are extreme outliers. So when there is somebody in the neighborhood who's having a high salary, then the mean is not a good representation of the data. So we will move to the second representation of the data, that is median. And this is a robust measure, and this is not affected by the middle values. It's not affected by the outliers, sorry. So again, if you want to find out the middle value, that's the median, the first step is to sort the data. So the first step is sort the data, and then once you have sorted the data, you can find out the middle value. So these are the two steps that's involved in finding out the median. So if you look at this data set, 0 and so on, you first sort the data. So the lowest values go here, the highest values are the right hand side. You sort the data and find out the middle value. When n is odd, it's very straightforward to find out the middle value. It's nothing but the n plus 1 over 2th observation, if you want to go into the math. Okay, so it's nothing but if n is 9, it's 9 plus 1 over 2, that's the 5th observation. So the 5th observation is 1, 2, 3, 4, 5. So the median is 8. Okay, it becomes slightly tricky when n is even. So when n is even, so there are two middle values. Okay, the first middle value is n over 2. The second middle value is n over 2 plus 1th observation. So again, this is n over 2th observation, and this is n over 2 plus 1th observation. So we take the average of those two values, and this will give you the median. So here, how many observations are there? 10. We look at n over 2, that's equal to 5, and n over 2 plus 1, that's equal to 6. So 1, 2, 3, 4, 5. Okay, pardon me. This is n plus 1, and this is plus 2. So we'll look at the 6th and the 7th observation. Oh yeah, because again this was n plus 1 over 2, so that's obviously the first one. So the 8, so what is that? Where was I? Okay, so, let me erase these things first, so that I don't want to confuse anybody here. Let's go back. So let's go back to our thing. So it was, if n is even, it's n over 2 and n over 2 plus 1th observation, and then we take the average out of it. This is absolutely correct. Okay, so n over 2 is 5, n over 2 plus 1 is 6. So if you first sort the data, so 1, 2, 3, 4, and 5th observation is 8, and 6th observation is 9. So it's the average of 8 and 9. So it's 8 plus 9 over 2, so that's 8.5. So again, sorry for that obstacle. The mistake which I did is I forgot to sort the data, and then I was searching for something that was not there. But again, the first step is always sorting the data and then finding the middle value. So that's the mistake I did, and now you know what to not to do. Okay, let's move on. So we've looked into mean and median. Mode is what we looked into before. So remember, we were talking about unimodal distribution. So this is the observation that occurs most frequently in the data set. So the most number of observations in the data set belongs to this category, and this category is called the modal class. So one way to find out the mode is using the bar chart. Bar chart is a quick and dirty way. So let's say in this case the mode will be 0, because 0 occurs 1 and 2 times. So other values don't occur more than 1 times. So 0 is the most occurring value in the data set. So 0 is the mode in the data set. If you're using Excel and if the distribution is bimodal, that means it has 2 modes. So again, we'll go back to our example 0 1 0 1 2 3. Here is having 2 modes, 0 and 1, because 0 and 1 both occur 2 times while other values occur 1 time. So if you're using Excel to find out this mode, it will always give you the minimum value. So if I put this value in Excel and use the function mode, it will always give me the minimum value, that's 0, okay, out of this 0 and 1. So be cautious about that. And let's try to summarize these three central location measures. So mean, median, and mode. The first thing is for a symmetric distribution. Again, this is a very plain example. For a symmetric distribution, mean, median, as well as mode will coincide. So they will be the same for the symmetric distribution. Mode is the one with the highest value, mean is the average, and median is one in the middle. So you can see that this will happen for the symmetric distribution. But what if the distribution is skewed, like let's say this? For example, the first thing that you have to find out is what kind of skew is this. So this is negative, this is positive. So this is the positively skewed distribution. Okay. Now we argued that mean is affected by the outliers. So there are some outliers, there are some values here. So if I tell you these 3 values, let's call them A, B, and C. So which one do you think is the mean, which one do you think is the mode, and which one do you think is the median? So let's say A, B, C. Okay. So the first thing to notice is, if the mean, median, and mode exist, the mean is the one which is influenced by the outliers. So the mean is the one which should be pushed to the extreme. So mean should be the C here. So this should be the mean. Okay, affected by outliers. That's a hint here. Mode is the easiest to notice. So the mode is the one having the highest number of observations. Again, remember that on the y-axis we had the frequency. So the highest number of observations correspond to the peak, so that's A. So this is mode. And then we are left with the third one, that should be the median. Okay. So that's a way to understand that in the skewed distribution. Okay. Let's move on. And what I will suggest you to do is look at this. Let's look at something like this. So this is a negatively skewed distribution. So again, convince yourself which one is the mean, which one is the median, which one is the mode. Let's C, B, A. Okay. So convince yourself that this same thing applies here too. Okay. So that's for your practice. Okay, we'll talk about other things later.